Hello everybody, my name is Corey Ross. I'm a rigger and 3D generalist. Um, and this is going to be my first rigging tutorial series. We're going to go over, quadruped setup. It's really going to be a couple different categories we go over. Spine, hind legs, front legs, um, maybe some space switching on the head. Otherwise the head isn't really that much different than, a human head or anything. It's really the spine and the legs that vary differently from other rigs you may have done already. So this video we're start with the ribbon spine, and what the ribbon spine is a set of joints that are driven by a NURBS surface. The NURBS surface being the ribbon. And how we get them to follow is with the set of follicles, and then bind joints on this NURBS ribbon. So really, we can just jump right into it. We'll start with a NURBS plane, and I like to do 7 spans. So width 1, length 7. And the reason I do 7 spans is so we can have 7 joints for the spine. So U patches 1, V patches 7, and this is because I have my model lined up along the Z-axis here, which it should be anyway. So go ahead and create. So there's my NURBS plane, i.e. NURBS ribbon. And we'll be moving it into place, but let's take a moment to look at these number of CVs on here. So you see we've got, just as with NURBS curves, 2 on each ends, and then one set for each span. And that's in the V direction. But in the U direction we've got it going 4 across. And, that's fine, but we don't really need 4 across, just 2 across. So I like to also go in and rebuild this. So under Edit NURBS, Rebuild Surfaces. And again, it's the U that we want to change. The V is going to stay the same. So number V spans 7, U spans 1. U degrees linear, that'll give us just 1 at each end of it, so 2. And the degrees V, we leave it cubic. So rebuild. And let's look at it now. There we go. So you'll see not 4 across, just 2 across again, 1 for each side. That's what we want. So now we can kind of move this into place. And what we want to do is get this curve and profile to match the shape of the spine. And we also want these spans to be roughly even in size. So we'll go into side view and just move it up to start. Now you also have to think about where you're going to place these joints, where the spine ends and where the spine starts. So the spine will start probably around here somewhere, and then we'll have a little connection for the tail and stuff. And then the spine will probably end somewhere around here. And we don't want it to follow the actual surface along the top of the spine, or the top of the back, because that is where spines are. But to help, with the skin weighting and stuff, we're going to move it a little closer to the actual center of the model. So this is as close as we're going to get it. Just moving it around. We can also scale it out. That'll keep the things nice and uniform, so we can scale it out a little bit and move it. But really, what we're going to have to do is go into CV mode. CV mode, and a little bit of soft select. We'll inevitably have to do a little bit of tweaking, I'm sure. And really, let's try to follow this edge loop kind of, but bring it up to the middle of where it comes into the neck. So bring these up here. Bring this. That's pretty much where we need it to be. Alright, turn off the soft select. And for those of you who might not be familiar with Maya, B is soft select. Although I assume you guys are familiar with Maya if you're rigging, so just move these into place. And this tutorial series is really about the the practice of it. My placements and everything might not be exact. I'm going to try to get as close as I can. But for the sake of time and convenience, I'm not going to spend too much time doing this. And think about, the way you want it to be shaped. So this is probably not quite right. Because they do have a little bit of a slope in the back, and then it kind of comes back up around the tail. So what were we talking about before? Where the spine starts and where the spine ends. So here you can see the spine kind of starts at the top of what is the dog's pelvis. And you can see the dog's pelvis doesn't really just go straight down. It goes down at an angle. So where the top of the leg is, really you go forward a little bit, and that's where the spine's going to start. And we're going to incorporate this kind of structure into the rig. So we do want to follow this. So really our spine's going to start somewhere a little bit forward of where the leg joins in. And also, you can't really see it, but the spine ends, right about here behind the scapula where the neck starts and, the rib cage ends. So again, really we kind of go up to where the leg meets the body and go back a little bit. And that's really where we're going to put this spine. And you can see in the edge flow, I've also done this model. So you can see that I've kind of modeled with this scapula in mind because I want that to have that deformation as well. And looking back here at the back leg, we've got the knee, and really the leg comes into the body probably somewhere back here. So again, around here is where we're going to put the base of that spine. So we'll go ahead and continue with that. Oh, and one last thing. Looking at it, again, you can see the curve. So it's kind of curving down as it comes into the spine and up. So we want that too. And right here, it's a little exaggerated. And the reason it is that way because I wanted it to reach a little further down into the body, but still kind of have that right shape. So it's a little bit of exaggerated shape, but that will be all right. Looking at it, I know that these are too far back. So I'll move those forward a little bit. And, move them down just a touch. Because again, we don't necessarily want this to follow too close to the top of the back because it can cause some issues for skinning. So sometimes we do break the anatomy a little bit. All right, so honestly, this is all probably fine for the sake of demonstration. I might tweak it later for myself, but we can move on from here. All right, so once you have the spine or the ribbon in place, and you can see it in there, it's still centered in X. And we have all of our spans, but now it's in the shape of the spine. We can really just go ahead and hide all this other stuff. We don't need this. I'll just rename it so I know what it is. And hide that layer. Because really, all we care about right now is the spine. And again, looking at it, I might just tweak this shape just a little bit. It's losing its curve a little bit. There we go. And remember, the other thing we want to check is the spans. It could be a little more even. So we'll tweak that now. All right, and again, honestly, good enough for demonstration's sakes. Really, I would probably spend a little more time on this, but we'll move on. So next up we've got the ribbon. Now we need follicles for the joints to follow. Anybody who hasn't done any work with dynamics or anything, that's no problem. We are using a dynamic system to get these, but we're going to delete most of the objects in the dynamic system. We're really only using the follicles because they attach to the surface. So go up into your End Dynamics menu, and I am using an old version of Maya here because that's the commercial license that I have, but most of these options are the same in 2015. I haven't seen 2016 yet, so. But End Dynamics, have your surface selected, go to End Hair, create hair options. All right, let's think about how we want these spread out again. I'll just reset these settings. Okay, so if you remember when we made our curve, the number of spans in V we had 7, number of spans in U we had 1. So here U count 1, V count 7. All right, how many points or how many hairs per clump? Only 1. We only need, sorry for that noise. We only need 1 hair per clump. So change that 10 to 1. Points per hair doesn't really matter. We're going to delete them anyway. Length doesn't really matter. We're going to delete them anyway. New hair system, that's fine. Create hairs. All right, what do we have here? We have a hair system. It created curves. These would represent the hair and anything else. But if you look really close, you see all these little red points. These are the follicles. These are the only things we really want out of this. So we'll go to our outliner. And here it is, hair system 1 follicles. There's all of our follicles with empty transform nodes in their curves. So, I'm not too familiar with the dynamic system, but I assume it has something to do with the actual curve of the hair. And although we'll be getting rid of the hair curves, I like to leave these curve nodes in here because then they really just become empty transform nodes that we can occupy with something else, and we will. So what do we need to get rid of? Get rid of hair system, get rid of paint effects hair, and get rid of nucleus. Let me turn everything. For some reason, yeah, there it is. There's nucleus. But we're going to delete all those. Again, hair system 1, paint effects, nucleus. Gone. What do we have left? Well, we have our nerve surface. Good, we still need that, of course. And all of our follicles under the hair follicle group. Perfect. Now, to get joints to follow all these follicles, we need to put them in there. There's, you could create the joint, animation, preset, or menu set. Oh, over here. Create a joint, right? And then you could put it under one of these curve node things, one of the curve group nodes or empty transform nodes, and zero out the transforms. And there you go, it pops right there for you. But there's easier ways. You could just select the curve node, and down here in the mel line, type joint. Helps if I spell it right. All right, so we got a joint already. That again was easy. I do like this a little better because if we look, it actually matches the orientation of the follicle. The orientation of these joints doesn't necessarily matter, but again, just for consistency's sake, I prefer it this way. So I'm going to get rid of this one and do this one the same way. And let's go down to the next one. And you can just hit G to redo it. Excuse me. G, 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 G. All right. Got my 7 joints, and again, they're a little crowded because I didn't space out these spans quite right, but that's all right. Gonna reduce these guys' radius down a little bit. So let's see what we've got here. If I grabbed these control vertices on the nerve surface, so you soft select so it has a bigger range, and I move these around, look at that, the joints follow. So these are going to be our bind joints that actually gets bound to the mesh. So I'm going to take a moment to actually rename these all so I know exactly what they are. I'll come back after they're all renamed. Okay, so here we go. I've renamed them all here. You can see them in the outliner. Spine 1 bind, spine 2 bind. And sprinkled throughout this tutorial series, I'm going to kind of include some of my tips and tricks for anybody who's just starting off rigging. People who are a little more veteran probably already do this or have their own version of this. But in this case, naming conventions. It's very important to remember that. I especially am concerned with naming conventions when it comes to bind joints, because in most rigs, and this one included, we're going to have multiple joint chains. So it's not as simple as select all the joints, select the mesh, bind the skin. We'll have to pick specific joints, and a lot of them are going to be overlapped with each other. How do we easily select them? Well, what I do is I make sure I name them all the joints I want bound to the mesh with a certain suffix, in this case capital B and D. And why I do this is so when I'm done and I'm ready to bind it, I can go up here and do select by name, and I type in BND, and I put an asterisk before it, so that means there can be anything before this, and an asterisk after, so that means there can be anything after that. So when I execute this, hit enter, what it's going to do is going to look through all the objects in the scene and just look for anything that has BND in its name. The asterisk means anything can come after that, and anything can come before that. I have the outliner open. I've typed in B and D with the asterisks, and watch what happens when I hit enter. It has selected all the joints that I've labeled with that B and D suffix. So, a little extra thought in the beginning makes it easier to select all your things at the end. Okay, moving on to the actual ribbon setup. Alright, so we've got our bind joints, and they're following the ribbon quite nicely. How do we pose this ribbon? With another set of joints. One at the tip, one at the end, and one in the middle for helping to shape it. So we want them in the exact same spot. So the easiest way I really think to do it is just select all the 3 joints that we're going to use as control joints, the end, both ends in the middle, and duplicate them. Immediately hit Shift P to take them out of the hierarchy. And over here at radius, we'll make them a little bigger so there's some visual distinction. So these 3 are going to be our our pose joints. And if we go ahead and move this NURB surface around again, you'll see that they're not influenced by this NURB surface as the other ones are. We'll actually make these influence the NURB surface instead. But let's go again and rename these. So spine 1, and I like to say pose joint, spine 2 pose joint, spine 3 pose joint. Helps if I can spell. Alright, so there we go. We've got our 3 bind joints, and we'll actually skin bind it to this ribbon. So select your joints, select the ribbon, skin bind, smooth bind. And again, if you're using different versions, you'll have different options. But for this, really all we actually want is closest distance. Number of maximum influences. There are only 3 joints. But in reality, we don't want this base joint really to have any effect on the tip. So 2, max influence of 2. Maintain max influence, in this case doesn't really matter, but I like to leave it off. Fall off rate 5, or drop off rate 5, that's pretty alright because it'll have a quick drop off. Bind skin. So let's see. Now this joint should affect our chain, and it does. And we can see it's not really affecting the other end at all, which is fine. But I may have wanted it to affect the middle a little bit more than it does. But honestly, we're going to set up another system so that this joint kind of averages out between the other 2. So in actuality, this is probably all right, at least for the sake of demonstration. So we've got our 3 joints set up to the NURB surface, which has the follicles on it, which has the bind joints under it. Now we need to set up our control shapes. I like to use cubes, and in my other versions of Maya, I have a script that makes the cube for me, but I don't have that loaded here. But that's okay. This will be kind of a quick demonstration on how you can get a NURBS shape, a 3D shape out of a NURBS curve that isn't just separate parts. And what I mean by that is if you do like, even if you create, I don't even know if there is that option, like a NURBS cube, it's really all different. This one's, I don't know. Yeah, see, this is the NURBS cube. They're all different sides. So even if we made this non-renderable or something, you know, it's all different surfaces, not what we want. So here we have a polygon cube, and what we'll do is we'll take our curve, you know, a little UP curve, I think this is, yeah, UP curve degree, we'll make it linear, which means that the curve will actually be straight lines. Turn point snap on, and draw on the points of the curve, or on the cube. And we'll go all the way around, and there'll be some overlap, but that's okay. Basically what we want to do is make sure that every edge of this cube is covered by the curve. And taking a quick look, you can kind of see that blue edge along it. That's the curve. All right, so we got them all. We can hit enter. Select the cube, delete it out, and now we have a NURBS curve in the shape of a cube. So that's another little trick if you guys weren't already aware of that. Most of you probably are already, but alright, so now I've got my cube. I'll put it in where I want it, which is right there. And I'll duplicate it. And put one at the end. And here I might turn the body back on because, you know, I would want my control shape to match the geometry. So I might, you know, actually shape it here so that it matches the geometry. But again, for demonstration's sake, doesn't really matter. So I'll turn that back off, and we'll just leave it as it is. So we've got our two control shapes at either end. We'll freeze these transformations. And we need a control shape for the middle. For this one, I just like to use a circle. NURBS circle. We don't need to do that point snap curve draw because this is one continuous curve already. And size it to fit. Again, I would normally turn this on and size it to fit the model, but we don't need to do that right now. Alright, this will do just fine. So let's freeze all these transformations and rename them spine base control. Again, naming conventions, I use CTRL for control, which means control shape. Spine mid control. Spine tip control. Alright, and the easiest way to get these joints to follow this curve, or our control curves, is to just parent them under it. So select the pose joint, which, as you might remember, is the larger of the ones there. Just parent it under that. So select the joint, select the curve, P to parent. P to parent. Alright, so now let's just test them out, move them around. Great. Everything's working nicely. Check this one out. Okay, so you could call this done, but is it really? We've got our control shapes that are driving the NURBS curve, which drives the follicles, which drive the bind shapes. This could be used to animate as is. But, you know, if this was actually bound to the dog, you can imagine I'd move the tail end of it, and nothing forward of it moves at all. Like, I can move it up and we get this crazy shape, and maybe that's a shape I want. But actually what would happen is if I move this up here, I would kind of want there to be a fall off. I'd want the curve to kind of maintain its shape, but just match itself to meet this controller. And then, you know, give me the option to take this mid one and move it to change the shape if I want. So we're going to set that up so that this mid one kind of follows both of the tip joints. We're going to do that through a series of point constraints, aim constraints, and parent constraints. So honestly, this is probably the most complicated part of this video because of the hierarchy that it entails. But again, we're just going to jump into it, and I'm sure you guys will keep up. So what we're going to need is two locators located at this controller. And those two locators are going to be under a group node. And we will also want this curve shape to be under a group node. Excuse me. And the reason we're putting these things under group nodes is, especially with the control shape, is the group node is going to act as something called a buffer node, or what I call a buffer node. Call it that because that's how it's been taught to me. And in rigging, you usually want to use buffer nodes. And that is because if you have a constraint, let's say if I constrain directly to this NURB surface, with these two, like because we'll be doing a point constraint on the group that's above this controller. But if we, just real quick, did a point constraint, let's find that, maintain offset, that's fine, add. So we can look at this constraint. There it is. We've got our two inputs, both ends. So we can move this up, and it kind of follows with it. Again, it's not doing what we want. We're going to put some aim constraints in so it has a rotate. But you can see it's following its translates. But watch what happens if I want to try to change this shape out, and then I move this again. It snaps. You see that? I'll do it again. It snapped. And the reason it snaps is because if we look at this control shape, it's got direct inputs into translate coming from, well, they're not direct inputs, but they have inputs coming from the constraint, this blue color. So that means if I change this, I can change it, but they're also getting inputs from the constraint. So if you change anything within that whole constraint system, it overrides those and it snaps. So that's why instead, let's just undo all this. Take this curve, delete this constraint. This is why we put it under a group node. I grouped it. I put the pivot at the bottom. So I did Control G to group it, hold D and V and middle click, and it'll snap the pivot there. So now I've got my control shape under a group node. And now if I constrain this group node and hold Command on Mac or Control on PC and select the group node and do point constraint again, it's following it the way we would want to, but if we select this, look, no blue inputs. So that means I can move this wherever I want, and when I move this, it's not going to override the translates on this, and it'll still follow with it. So no snapping. That's what we want. So that's why we put these things under group nodes. And that's why buffer nodes are usually pretty important. If you want something to have some influence from something else, but you also want to be able to pose it independently of that influence, you use a buffer node. So, and that could be a group or a locator or really any transform node you want. So I need that point constraint on there, but not actually from these two ends. So we're going to get rid of that. We'll keep the group node, but the point constraint was just for demonstration. So what else do we need? We need the two locators. So animation toolset, locator, just create both of them. And we need to group these. So Control G, we've got our group. And we need to move it up to the center. So in move mode, hold V for point snap and move it up. There we go. Let's expand this out, and we'll call this mid control aim group. And it doesn't really matter which one's which, but one's going to be base aim locator underscore LOC for locator. And the other one's going to be tip aim LOC for locator. Alright, so I have these two locators. And what am I going to do with them? I'm going to aim constraint them to these two controllers, respectively. So let's select the tip one, Command or Control select the tip aim locator, and we're going to do constraint aim. Let's take a look at options. So if you haven't used the aim constraint before, there's a lot more options in here than other types of constraints. So aim vector, it's which axis points at the target. So you can have it just one axis. In this case, the x-axis would be pointing towards the target because this is x, this is y, this is z, and x has 1, the others have 0. If we wanted it to be like a 45-degree relation between x and y, we put these both at 1, and it's going to average between the two of them. But really, we don't want either of that, so these are both going to be 0. And if we look at our locator, which axis is already kind of pointing towards this? It's this blue axis, which is the z-axis. So x, y, z, make that 1. All right, which axis is the represents the up vector? Well, that's y. It's already y, and we've got 1 and y. That's fine. World up type. So this is where this kind of constrained object is going to get its up orientation. So it's like it's twist. We don't want it to be vector. We want it to be object up. So it's going to follow the same up vector as another object. And that kind of opens up this field. So we have to put an object from our scene in here. And that's going to be our control shape that we're constraining it to. So we can just copy the name, paste it in here. And again, to make this constraint work, we've got to make sure we select the constraining object first, then our constrained object. We've input all the values we want. I like to leave maintain offset off, so that way it does. You'll see that it kind of snaps to point at it, and we can hit apply. And if we look at it, we can see that this locator is now pointing at this controller. Perfect. We'll do the same thing from this base to the base locator. Now, we do have to change just one setting, and that is the aim vector. Because as we can see, it's no longer z that's pointing at the controller that's constraining it, it's negative z. So we'll just go over here, make this negative z. Oh, and we also have to change this name. So it's not spine tip control, it's spine base control, and apply. And again, now you can see we've got two locators. Both are pointing or have oriented themselves to kind of point at what we want. Great. And we've got we have them all under a group node. So if we move this one, you can see there's the one locator is rotating to maintain its aim constraint. And if we move this other one, it's doing the same. Very good. But we also want these locators to follow translates, right? And again, we're going to, since they're under one group node, we can just point constrain that group node. So select both end controls, control or command select the group node, constraint, point, maintain offset on, all axes, fine. So move it up, and we can see the locators are following with it and rotating to maintain their aims, but it's not carrying this controller with it, which is what we want it to do. So what do we do now? Well, we just take a look at, we're going to take these two locators and parent constrain them to the group that mid controller is under. So select both locators, command or control select the group node that the spine mid control is under. And really, these group nodes should be named as well. I've just gotten a little lazy, but we'll go ahead, constrain, parent them. Let's check maintain offset, all axes, fine. So now, before we did that, these locators were inheriting, or they were getting translate and rotate values from the two end controls, and now through the parent constraint, they are passing them on to our mid control. And since we have two influences, it's going to average them out. So let's see what this does. Look at that. So now, when we move this end control, not only does the mid one follow it, but we're maintaining a nice curve. Before, I don't know if you remember what was happening, but it was kind of curving and flattening out and curving again because this mid control wasn't getting any rotates, it was just getting translates. But now it's getting both. So now the mid one is moving with both and rotating with both. And we can kind of bring this down. We could rotate this out like that. We could also use this mid one to change the pose however we want. And really, that's the whole ribbon setup. and you can see it still follows with. These locators are a little offset, but they're still doing their job of maintaining that relationship. And really, when you're using the rig, you would turn locators off anyway, most likely. So, the animator's not going to see that. They're not going to think something weird's happening, and everything is working the way it should. So, there you go. That is the ribbon setup, and we can just select all these, zero them out, and we're back in the bind pose. Let's just turn the body on again, and we can see that it's sitting in there nicely. And so again, we wouldn't in turn bind this to anything yet because we don't have our other bones, but you can see how the ribbon setup is going to work. And again, you would just use asterisk, BND, asterisk, and you'd get your bind joints, and you would bind those to your mesh. So again, the reason why we do ribbon instead of maybe a spline is, we could get the spline to act the same way. However, there are two functions of the ribbon spine that kind of come inherently to it that you would have to do extra work to set up with a spline. One would be stretchy. If we pull this way out, it stretches to match no matter what. And that's because it's driving a surface which is driving the joints. And the other thing, and this is for the same reason because it's bound to an actual surface, is this rotate down the chain. You can see that we're getting a nice rotate, a nice twist. And if we were to do a spline setup for this, like an IK spline, it would take a lot more work to set this up. So the ribbon spine, I think, is a nice quick proxy for that. And it's stable. It's easy to animate. So it's really a good solution. And I've used the ribbon spine for bipeds as well before. So really, it's not to say that spline for bipeds, ribbon for quadrupeds, they're kind of interchangeable. But this was just a good opportunity to hopefully teach you guys something new about ribbons. So yeah, in conclusion, this is the ribbon spine. This is the specific setup with the ribbon spine I would use for a quadruped. And I'll include a demo file with this setup. I'll exclude the geometry just because that's part of a rig I'll be releasing later. But hope this helps, and good luck.